Alright, let's look at some basic game dev in this video. We'll be building the famous snake game using Python and pygame. So first let's look at what we're building. Then we'll look at the high level explanation, sort of the algorithm we'll be following, and then finally we'll look at the code. Feel free to move ahead by following the timestamps. They'll be there in the description. And if I run it, so this will be the final output. So you can see that this is the snake game. And we have the snake here and I can move it by my keys, and if I eat the food it gets incremented and the score also gets incremented. So this is what we'll be building in this tutorial. So yeah, that's the main agenda of this tutorial. So let's look at how we'll do it. So we'll be using pygame to implement this game, and so first I'll basically walk you through the algorithm. So the snake is basically a collection of coordinates which is stored in a list, and in order to move the snake, what we'll do is we'll append one coordinate to the start of that list and delete one coordinate from the end of that list. So that is how basically how the snake will move. So if we look at a simple explanation to it, so if imagine if these three blocks were your code, were your snake, so we'll be adding one block in front of it, and we'll be removing one block from the end of it. Okay, so I'm adding one block and I'm removing one block. So in this way the snake will move. Next, the snake has to eat. Okay, so the size of the snake or the length of the snake has to increment as it eats. So in that I can basically implement that if the position of the food matches the position of the head of the snake, then I will increment the length of the snake. And if the coordinate of the head of the snake matches any other coordinate of the snake, we'll basically kill it. So that will be the basic algorithm of the game. If you did not understand it, there's no problem because we'll be coding the entire thing right now in this video. So the 5 steps are basically, first we'll set up the game and the pygame, and then we'll add a moving snake, we'll add food, we'll add the game end condition, and then we'll add some final touches, which will basically be the score and the high score functionality. Okay, I hope that's clear. Even if it's not clear, it will get cleared up with the code. So let's dive into it. So first let's look at the structure of the code. So we'll basically have a snake class and a food class. So the snake class will contain all the properties of the snake, its attributes and all the functionalities which the snake must have. And the food class would consist the similar stuff for food. And the main function will contain our main loop, which will basically be the implementation of our game, which will basically keep it running. We are following the object-oriented approach here. So even if you don't know the approach, you can follow this video and maybe you gain some insight into it. It's a fairly easy approach. We are just having two classes and we'll be just calling the methods directly from our main function. Okay, so let's first build the pygame window. Okay, so I have my snake class and food class here. So first we need to initialize the pygame. So pygame dot init. So this initializes pygame. Then I'll have a clock. So clock is basically to control the timing or the speed, the frame rate of your game. So that will be pygame dot tick dot clock. Okay, and I need to have a window where all this mechanism or all this code will run. So I'll have pygame dot display dot set mode, and here I'll have to specify the width and height of the screen. So I'll be declaring them as global variables. Okay, and let's have a caption for our game. So I'll have pygame dot display dot set caption. Okay, so this is the caption of our game. Now let's set the loop. So it will be a while true loop. It will run infinitely until we stop the execution. So first let's add the exit condition, which is pressing the cross out here. So we'll be looking at the event in which a person presses that cross. In the top right corner of your window. So for that we'll have for event in pygame dot event dot get if event dot type is pygame dot quit, then I'll quit the code and we'll return. Okay, so this is um, the basic initialization of pygame, and let's see if we can get some output out of it. This is time. Okay, so let's define width and height as global variables. So width is, let's say, 400, and same goes for height. Okay, and yeah, so this was time, not tick, and let's execute it. So as you can see, we got a blank window out here. Okay, so let's give it some color. So we'll call a function to set the background color, and we'll make it a function as we'll need to set it multiple times. So let's add a function out here. So set background, and we'll pass the window because we need to color this window. Let's define it. Window is the parameter, and let's say I'll give it a lawn color, grassy color. So let's see, and pygame dot display dot update to update the color in this window. So yeah, okay, so this is the basic window of our snake game, and we'll perform all the functions out here. So I hope that's clear. Okay, so our snake is basically a bunch of blocks which travel in this window, right? And the food also will appear in a block, so we can visualize our window. So the window which we saw here, so we can visualize this window as a grid. Okay, so let me show this to you in the original code. So let's look at the grids. So these are basically the grids which you can imagine, so that we can visualize our code better. So the snake is moving in this grid. Okay, so specifying the coordinates becomes much easier when we are visualizing it as grids. So we just need to specify the coordinate of the particular grid block. So you can imagine each of these cells as blocks. Okay, so the snake is containing 3 blocks. Okay, so if we specify the coordinates of these 3 blocks, we'll be able to make our snake. And the same goes for food item as well. Okay, so we'll specify the coordinates of this block, and this food item will be specified. Okay, so this is the grid, and the snake is moving in the grid, and you can see that it is not overflowing or overshooting any block. Okay, so that is the main purpose behind introducing this concept of defining it as grids. So let's say we need about 20 grid lines. Okay, so I'll just specify the grids which we need to have here. So let's say grids is equal to 20, and we can have grid size, which is basically the block size, as width divided by grids, number of grids. Okay, so this will be the size of a block. We'll require it because we'll be making some rectangles based on the coordinates of the snake, and out there we'll need the grid size of the block. Okay, so now we'll draw a snake in the window. Okay, so we want to put a snake on the screen. So there you go. So I have defined the length, position, color, direction, and score of the snake. So the length is 3. It can be any other number. So the position is basically the coordinates of the snake. Okay, so since we are specifying the length as 3, so we'll have 3 coordinates into the snake, and those 3 coordinates will correspond to 3 blocks. Okay, so I'm adding it at the center, so I have width by 2, comma height by 2, and then I've added the grid size because according to the direction you will add the remaining blocks. Okay, so I've basically hard coded the 3 blocks of the snake, and it will appear in the middle of the screen. And you can also use the random library to generate random coordinates, that is fine. And this is the color of the snake, and this is yeah, so this is the color of the snake, and so this is the direction, which is up. So I'll be defining up in the global variable just a minute. And this is the score, and we won't be using score right now, but we'll be using it in the functionality later. Okay, so let's just keep it there. So these are the attributes. So our snake needs some drawing, so we'll add a draw function out here. Okay, so let's say let's call the function as draw snake. So draw snake self comma window, on the window on which it is drawn. So for every block in the position we have to draw a rectangle, right? Because we have 3 coordinates in our positions array. So for in self dot position, okay, so these are the blocks. I'll have pygame dot draw dot rect. So I'm drawing a rectangle on the window, and the color will be equal to the snake color which is specified, and I have to specify the specifications of the rectangle, so which are the top left coordinates of the rectangle and the width and height of the rectangle. Okay, so that will be nothing but block 0, since block is nothing but the coordinates, right? So block 0 comma block 1 are the x and y coordinates of this of the snake's block, and then I'll have grid size comma grid size, since grid size is the width of the block. Okay, so yeah, this should basically draw the snake. And so now let's call these functions. Okay, so yeah, so we'll have to define the directions as well. So let's say out here only, so just the directions. So my up will be 0 comma -1. So the basic logic of defining these directions is that, so the plane of the pygame window, so that has the origin at its top left corner. So as we move towards the top of the screen, the y coordinate decreases, and as we move toward the bottom of the screen, the y coordinate increases, right? So when I press up, the snake has to take a 90 degrees turn to the top. Similarly, when I press down, the snake has to take a 90-degree turn towards the down, or towards the downside of the screen. Okay, so when I'm taking the up turn, my y coordinate is decreasing while my x coordinate is remaining the same. Okay, so similarly I'll have to write it for all. So down would be 0 as the x coordinate would remain the same, and 1 as it is moving away from the origin. And there will be left will be -1 comma 0, right 0 comma 1 comma 0. Okay, so I hope this is clear, and we'll just declare the snake object now, and we'll call the snake. Okay, snake is equals to snake, and let's create one for food as well. So let's draw the snake now. Snake dot draw snake window. Then let's have an update. Pygame dot display dot update. Okay, let's check this out. Okay, so we got our static snake out here. So now let's add some life into it. So we'll add a movement function for our snake. So as I discussed in this image earlier, we have to add a coordinate to the start of the list, and we have to remove a coordinate from the end of the list. Okay, so that is how our snake will move. Okay, so we are adding one and removing one. So let's add the movement function. So I'll pass self, and okay, so the head will be the first element of the array, and it will be self dot position index 0. Okay, so this is the first element of the array, and we need to get the direction as well because we need to move in that particular direction. So self dot direction. Okay, and now we have to generate the extra coordinate which has to be added. Okay, so that will be based on these two parameters. So let's call it next. So next is equal to, so head is basically the starting coordinate. So for the x coordinate, I'll have to basically add the so I'll have to add the direction times the grid size to this coordinate to get the coordinate of the next block. Okay, so if you can visualize this, I'm at a coordinate x and I have to move to the next block. Okay, so if I have to move to the next block, I'll have to add the width of that block in that direction. Okay, so I'll have to add x times grid size. I hope this is clear. So this is basically the next block in that same direction. So if we're moving towards the top, we have to subtract, right? So that is why we have to add this parameter of x out here. Okay, so this is the x coordinate. So let me just write it in this way. So this is the x coordinate, and let's write the y coordinate. That will be head of 1 plus y times grid size. Okay, and now we want to have it as a wrapped representation inside our window. So what that basically means is that whenever I touch the boundary, it should get redirected into the playing field again. So that is why I'll add a modulus. Okay, so adding the modulus would ensure that whenever I cross the playing dimensions, it would be redirected back into the dimensions. So I'll add height, and here also I'll add width. Oops. Okay, so yeah, so this is the next block which has to be inserted, and then I'll insert it. So self dot position dot insert at the start, I'll insert next, and self dot position dot pop to remove the final block. Okay, so I guess this should do for movement. So let's call movement as well. Let's add the movement here, snake dot movement, and we'll also set the background because we need to refresh the background every time we move the snake so that it can go back to its original route. Otherwise it will keep on adding the snake onto the same background, so it won't feel like the snake is moving. Okay, let me actually show you how that would look like. Yeah, so that looks like this. So that is why we need to set the background, and we need to set the clock as well because it's moving pretty fast. Right now we weren't able to see the snake moving, so that is why I'll have to first set the clock dot tick. Let's set 12, and here I'll add set background, pass the window. Yeah, this should do. Yeah, so we got a moving snake right now, so we can't change the direction or anything, but the snake is moving, and this is the first crucial step. So let's add the functionality of changing directions now. So for changing directions, we'll look for required events and then we'll assign the new directions accordingly. So let's add that functionality here with the event listener we already have. So if event type was quit, we were quitting. So we can add elif here. So elif, if there is a key down event, so event dot type is equals to key down. and then we'll add events of all the 4 directions. Okay, so this is the direction for up. So if my key pressed is up, the snake direction has to be up. But there is one thing to keep in mind out here, that if the snake is moving down, pressing the up key would not mean that the snake has to take a 180-degree shift. In fact, pressing the up key should have no effect. So that is why um, I'll add a check for that. So if not snake dot direction equals down. So if this is the case, then only we'll change the direction of the snake to up, because we need to make 90-degree changes only. We don't have to make 180-degree changes, right? So similarly, I'll add code for all of these. Okay, yeah. So I think we're done here. So we have added all the directions which the snake might take, and we have added all the checks out here. So let me just verify. Yeah, okay. So let's uh, execute the code. We have called all the functions out here, and it should okay, so there is an error. Okay, so this is pygame.keydown. Okay, I'm checking it. Yeah, so as you can see, we got our snake out here and it is moving very nicely. And so that was just with some few lines of code. So now the snake functionality is complete. We just have to check for game end condition, and that will not be right now because we first need to increment the length of the snake. So we'll look at food functionality here. Okay, so the food class we have out here, so let's populate this class. Okay, so first we'll initialize it like we initialized the snake. So so we'll have all the characteristics like the color of the food and the position of the food. So I think those two are only the main characteristics of the food class that we'll need to provide. So so let's specify the position. So self dot position is equal to, so I'll have to specify some random position out here. So I'll use the random library. So random dot rand int. Let me import random. Okay, I've already done that. And 0 comma width. Okay, so this will give me a random integer between 0 and 400. Now I have to map it onto the grid. Okay, so since I have to map it onto the grid, what I'll do is I'll divide this by the number of grids. Okay, so let's say my number was 390. So now it becomes 19. Okay, now we have to make it 380 because that will be the perfect coordinate for the top left corner of the grid of the block. So I'll multiply it again by grids. Okay, I hope this is clear. We're just making it into the nearest block coordinate. Okay, so so after that I'll have to add color. So self dot color is equal to, let's keep it black. Okay, and we also have to draw this food. So just a similar functionality as we developed earlier. So pygame dot draw dot rect, and we have to draw it into the window. So I'll have to take window as well. The window, the color would be self dot color, and the position would be the two coordinates of the top left corner. So self dot position 0 and self dot position 1, and I'll have the grid size and grid size. Okay, so this is the code for the food class, and we just need to call the food class out here. We have already made the object for the food class, so that is already done. and we just need to call the draw function. So we just need to draw the food. So I'll add it here with the snake. Food dot draw. Made a little difference in the syntax, but okay. Yeah, so I guess this should give us the food position. There's some error, spelling mistake. Here, position and position. Yeah, there's another error that I have not specified the y coordinate out here. So, so let's just copy paste it, and it will be 0 comma width, width comma grids. Yeah, it will be the same. Okay, so I have my x and y, and I have self dot position 0, 1 grid size, grid size. This should work now. Yeah, so I've got my moving snake and I've got the food object. So right now the snake will just pass the food object as if it's nothing, but we'll have to add the food eating functionality, right? So let's add the food eating functionality now. So till now we've got a moving snake and the food position. So to make the food eating functionality, we just need to check if the coordinates of the head of the snake matches the coordinates of the food. So if the coordinates of the head of the snake matches that of the food, we can say that the snake is eating the food, and hence we have to increment its size, and we also have to increment one block to its position. Okay, so if food dot position is same as snake dot position of the head, then that means the food has been eaten, and we need to increment the length of the snake by 1, and we also need to increment the score by 1. We have not yet added the score functionality properly, but let's increment it by 1, and then we have to append a block at the end. So right, there are two ways of doing this. So we can append a new block at the start or at the end. Okay, so if we have to do it at the start, we can simply append by using the direction as we did in movement. Okay, so like we are removing one block at the end in movement, right? So we can skip that step and we can just add at the start. So that is one way of doing that. And the second way of doing that is basically we can add it at the end. So to add it at the end, we don't know any of the functionality, like we're not keeping track of the direction, the historic direction of the snake. So we don't know what path the snake took to reach this place, right? So we don't know the direction in which we will have to add that block. So what we can do is we can consider the position of the last two blocks, and based on those last two blocks we can calculate the position of the incoming block by considering those three blocks in a straight line. So I don't know if this is the perfect way of doing this, but it works fairly well. So we'll be implementing that, appending a block at the end. So we are using the midpoint formula. So if we look at the image again, so I have my two last blocks out here. So let's consider these two yellow blocks as the two last blocks and this red block as the incoming block, just for example. So I have to get the coordinates of this block, right? So in order to get the coordinates of this block, I can say that the second yellow block is the midpoint of this first and third blocks. So that is why this midpoint is basically x is equals to x1 plus x2 by 2. So second is equals to first plus third by 2. Okay, so that implies that the third block is equals to twice the second block minus the first block. I hope that makes sense if you write it as a formula. So x is equals to x1 plus x2 the whole by 2, and then you get we have to basically find x2 out here. So x2 is equal to 2x minus x1. So we can implement this same functionality here to calculate the position of the new generated block with when we are eating the food item. So I'll have snake dot position dot append. Okay, so I'm appending at the end 2 times snake dot position, and we have to take the, so 2 times is the last uh, block, right? So as we discussed, 2 times the last block minus 1 times the second last block, minus snake, okay, minus snake dot position of the second last block. Okay, so minus 1 and minus 2, so minus 1 denotes the last position and minus 2 denotes the first position. Okay, so this is my x coordinate, and let's write the y coordinate, which will be exactly the same, just 0 will become 1. Yeah, so I hope this works. And we also need to initialize the food because we are eating it, so we have to get a new food source. Okay, so on eating we are incrementing the length of the snake, incrementing the score, and we are adding a coordinate at the end position based on the midpoint formula. You can also add by the same logic as movement. Okay, so let's check if we are able to eat the food now. So let's try, and we got an error. I don't know the spelling of position, it seems. Let's try again. Okay, yeah, so we don't need to end this. Yeah. So yeah, as you can see, our functionality is working now. This length of the snake is increasing. So the food eating functionality is also done. So we just have one functionality left now, which is the game ending functionality when the snake collides with itself. Okay, so that is fairly easy. So we just have to check if the position of the head matches the position of any other block of the snake. If the position of the head matches any other block of the snake, then we can say that the snake has collided with itself and we should end the game. Okay, so so let's add a function out here uh, in the snake class. So we'll add check game end. Okay, we'll have self, and we'll need window in the future, so let's pass it right now. Okay, so when the game ends, first I'll reinitialize the game because you want the game to continue. So dot init. Okay, so check the game ending condition. So that is basically if self dot position 0 in self dot position any block after 1. Okay, so if this is the case, then we are ending the game. So let's print this also. Okay, so if the snake is colliding with itself, and then we are also reinitializing the snake. Okay, I guess that's it for checking the game end. Let's call this, right? So we'll call it in the main loop. So check game end, right? Snake dot check game end, and we are passing the window. Let's check it out. So the snake is here. Let's see. Okay, the snake is incrementing. Yeah, good. So let's end the game now. Yeah, okay. So the snake size was reset to the first size, and the score was also initialized to 0. Okay. So now, so the basic functionality of the code is complete now. So we'll just need to add some um, aesthetics to the code. So the high score and the score, as well as the game ending message. So we'll add these couple of things and we'll quickly finish this off. So I'm just going to output some code out here, which will execute when the game ends. So there you go. So basically we have a high score variable. So I'll just define the high score. Did I make it all caps? No. Okay. High score is equals to 0. So this is a global variable for denoting the high score. So the player can have multiple iterations of the game. So the global high score should remain the highest score which he has achieved. So high score is self.score if self.score is greater than the previous high score. Okay, otherwise it remains unchanged. So I'm adding two text out there for game over and restarts automatically. So I'm choosing the font, and so basically text is for the text functionality. I have to specify the text, then true, then the color of the text, and then by using text.rect I basically get a rectangle in which the text will be stored. So I can center it by the width and the height of the screen. So I want to keep it in the middle, and I want to so I don't want to keep it in exactly the middle. I thought that if I subtracted 20 from it, I got a better representation visually, because it seemed a bit too towards the downside. So that's why I subtracted 20. And the same thing for restarts automatically. So out here I did not subtract anything because I've subtracted 20 from the earlier one, so the two must not overlap, and this text should come below that. Okay. And then using blit, I'm writing the text. So basically blit function is used to output anything to the pygame screen. So if I want to add some image or anything, I'll use the blit function. So I'm adding the text using this blit function. So I'm adding both these text and text2, and display update and time delay. So after 3 seconds delay, the game will restart again. Okay, and I'm calling the init function out here. Okay, so let's add the final functionality, and then we'll run the code in one. We don't need to run the code multiple times right now. So just the final stuff is left, which is displaying the score. So I'll quickly add the code for the high score and high score. So score is equals to, and snake.score, and high score is equals to um, the high score global variable, and I'm blitting these two text onto the screen. So I'm blitting all these four text onto the screen. So let's see how it looks. I hope it doesn't show any error. Oh, it does show some error, and my font is not defined. Yeah. Okay, so I need to define my font here as well. I defined it in the function, so that is why it's throwing an error. So my font is equal to pygame.font.sysfont, and I'll take Comic Sans, and let's keep it at size 20. So let's run this, and yes, this is the final output of the game which we wanted. As you can see, the snake is eating the food items, and the snake is also getting incremented in size. And let me just kill myself after eating this food particle. Okay, so yeah, so once I killed the snake, so it shows that message, and after 3 seconds the game restarts automatically. So let's try again, and let's not beat the high score this time, and see if the high score is being updated. So yeah, so game is over. So let's see if the high score was updated. So the high score was not updated, right? So this is the final game, and I'm noticing that there is some update in the screen. So I guess that is due to some ordering of the screen. So as you can see, there was some discontinuity or some updates in the pygame window that were happening, which were making it look a bit odd, a bit discontinuous. So I think it is due to the pygame.display.update, which you've called many times. So that can actually lead to problems. So let's comment that out and run it again. So as you can see now, the game is running quite smoothly and we have no errors. Yeah, so there is no screen updating or any discontinuities in the screen right now. So the game is functioning smoothly. Yeah, so that is it for this video, I guess. So we have implemented the snake game. So I'll briefly tell you the steps again. So we first created the pygame window, then we created the snake. We added functionality to the snake. We added its attributes and we added the movement to the snake. Then we added the change directions function, not the function. We changed the directions in the main loop itself, and we added the functionality for the food, and we added the game and check condition, and we added the aesthetics such as score and the ending message for the game. So I hope you enjoyed this lesson, and I guess it was fun for you. I hope it was fun for you. And if you liked the video, do subscribe for more content like this. And you can add more functionality to the code. So you can add graphics. You can add graphics for the food item. Maybe you can add an apple out there to make it resemble the original snake game. Not the original, but the one which came later. And then you can also add the snake's head and tail, which will also make it look much better. And the code will be there in the description, so you can go there and you can download the code. So that's it for this video. See you next time.